Hi all the students of Narayana 9th standard. Today here I am in front of you all to discuss assignment number 37, which is from the topic center of mass and collisions. Now from this topic, let us go with the first question. The first question which is given to you all over here is, a uniform disk of radius r is put on another uniform disk of radius 2r of same thickness and density. Perhaps the peripheries of the two disks touch each other. The position of their center of mass is. So the position of the center of mass, if you want to consider, and let us go with this problem first of all. Now when you go with this particular problem, you can take two disks. When you are considering two disks, let us take the first disk is like this with some radius r. This is radius r, and you take another disk which is of radius 2r. See, uniform disks. Okay, this is 2r radius completely. So now what happens is, if you are considering this, what happens, the mass of this is mass is pi r square d. Mass of a uniform disk is pi r square d. Now when you consider this, that means let us take the mass of the first one is m1 and mass of the second one is m2. From there, m1 is nothing but m1 is directly proportional to r square, whereas m2 is directly proportional to 2r square, which is nothing but 4r square. So I'll write it as 4r square. 4r square. Now, so I got m1 and m2. Now I want the displacement. Let us take the displacement. I want the center of mass with respect to the bigger uniform disk. So which I will be taking it as x is equals to m1d by m1 plus m2. Now d is nothing but the distance from the main disk, the distance from the second disk, which is of 2r. Now when you consider this, m1 is given as r square, and d if you want to consider, so d is going to be equal to r. D is going to be equal to r. So now that r is nothing but the distance from the second one to this one, which is r. Okay, so the distance from the second one to the center of mass. So that is actually r from to this where these both are touching each other. So let us take that r. This is r, and r plus r is 2r. Now d is taken as r. Now what happens is, if you try to substitute that values, you will get m1 as r square into d is taken as r by m1 plus m2 is r square plus 4r square. Okay. So now what happens, if you are considering this formula, then the x value is going to be somewhat around equal to r cube by r square plus 4r. R square plus 4r is 5r square. Now cube and this r square gets cancelled. You will be left over with r by 5 from the bigger disk. So option is r by 5. Let us see where that option is. Yeah, option number 2, which is option number 2 it is, which is r by 4. R by 5 we have discussed it. This is r by 5, right? So r by 5 from this bigger disk. So the option is second one, which is r by 5 from the center of bigger disk towards the center of smaller disk. So I hope this is helpful. Let us go with the next problem. When you come here in this problem, a particle of mass m, 2m, 3m and nm grams are placed on the same line, that means they are on the same line of lengths L1, L2L and 3L and NL from a fixed point. The distance of the center of mass of the particles from the fixed point in centimeters is. When you want to find this kind of a question, just first of all try to solve this by taking the center of mass on terms of x center of mass is equals to m1 x1 plus m2 x2 plus m3 x3, actually so on, right? So on mn xn by m1 plus m2 plus m3 plus so on mn. Now what happens over here is, when you consider this, what happens is m1 is taken as m, x1 is taken as L, plus m2 is taken as 2m, plus 2m into 2l, because x2 is taken as 2l, m3 is taken as 3m and x3 is taken as 3l, plus so on nm into nl by m1 plus m2 plus m3 plus so on nm is nothing but it is going to be m plus 2m plus 3m plus so on nm. Now this is the formula of x center of mass. The center of mass on this x. Now when you try to consider this, I will write this formula. I will take m and l common. Now what else is left over here? You have 1 plus 2 square plus 3 square plus so on n square by m plus 2m plus 3m plus so on m. So you are taking m you take common from the downward, you will get 1 plus 2 plus 3 plus so on n. So we know that from the series formula, what happens? L into 1 plus 2 square plus 3 square plus so on n square. Sum of the squares of the series is going to be n into n plus 1, n into n plus 1 into 2n plus 1 by 6 by n into n plus 1 by 2, n into n plus 1 by 2. What happens over here? You cancel this 2 1s are 2 3s are, n plus 1 is going to get cancelled, and you will be left over with L into, I'll write it over here, L into 2n plus 1 by 3. L into 2n plus 1 by 3 is your option 1, right? So the center of mass of the particle from the fixed point in centimeters is going to be 2n plus 1 by 3 into L, which is option number 1. Hope this is helpful. Let us go with the next problem. So in this problem you have masses 8, 2, 4, 2 kgs are placed at the corners of of a square respectively. A, B, C, D are they are diagonals, and the diagonal is also given. Sorry, they are the sides. They are the corners. At the corners of the square you have A, B, C, D points with masses 8, 2, 4, 2, and the diagonal is given as 80 centimeters. The distance of center of mass from A. Now when they give you this kind of a questions, what you will be doing is, you consider a small square. This is a small square which has A, B, C, D as its vertices, and the masses of these objects which are placed over here. Let us take the mass m1, which is 8, m2 is 2, 8, 2, 4, 2, right? So m1, m2, m3, m1, m2, m3, m4 are placed at the corners of A, B, C, D respectively. The squares A, B, C, D of diagonal 80 centimeters. They gave you diagonal which is 80 centimeters. And now the distance of the center of mass from A. I want the center of mass might be the center of mass somewhere, it will be around somewhere here. You can consider the center of mass, it might be somewhere around here or here or here. We will try to find out the locations. If you want to find out the center of mass of this particular thing, we have to consider that x center of mass and y center of mass. When we try to find out the x center of mass, we will be getting how much we will be getting is x center of mass is m1 x1 plus m2 x2 plus m3 x3 plus m4 x4 by m1 plus m2 plus m3 plus m4. Right, this is the formula. So from here, when I want to substitute m1 x1 and m2 x2 and all the four things we will try to give. Now let us consider over here, I will write it little neatly. m1 x1 plus m2 x2 plus m3 x3 plus m4 x4. Now let us consider this coordinates which is on x and y components. So 0, 0, here how much will be having? A, 0. Let us think this side is A and this side is also A. Okay, so this is how much? A, A, and here how much you will be having at this particular point? 0, A, right? X is 0 as well as y is A. Right, fine. Now let us substitute these values in x component. So m1 is how much? m1 is 8. x1 is how much? x1 is 0. Plus m2 is how much? m2 is 2. x2 is A. Plus m3 is 4. x3 is A plus 2 into 0 by 8 plus 2 plus 4 plus 2. 16, right? 16, and here how much you will have? 2A, 4A, 6A. So you are getting x center of mass as 6A by 16. X center of mass is given as 6A by 16. Now when you try to find out y center of mass, so I will write this. X center of mass, I will write it over here. X center of mass is given as 6A by 16. From this formula we have found it. Now let us try to find y center of mass. When you try to find y center of mass, how would you get is, you would get m1 y1 plus m2 y2 plus m3 y3 plus m4 y4. Now when you substitute y values again, what you will be getting? m1 is taken as 8, m1 is taken as 8, and y1 is taken as 0, because this is x1 and this is y1, x2 y2 and x3 y3, x4 y4. So here 0 plus and 2 into y2 is how much? y2 is 0 plus m3 is how much? m3 is 4, y3 is a plus m4 is 2 and y4 is a. Okay, so again you will get 16 in the denominator. If you add all this, you want 8 plus 2 plus 4 plus 2 is nothing but you will get 16, and in the numerator you will get 6a. This is nothing but y center of mass. Now let me write y center of mass also over here. Y center of mass is given as 6a by 16. 6a by 16. Now let us try to find out the center of mass from A. When you want to find out the center of mass from A, we got the center of mass coordinates. Center of mass of this particular 4 masses we got it, which is 16 by A and 6 by A, 6A by 16, 6A by 16 are the coordinates of center of mass. Now what I want is, they asked you the distance of center of mass from A. That means distance of center of mass from where I want? From A. Let us think that it is touching over here. Now what happens from X and from Y? Now X value, how much you got center of mass? 6A by 16. That means if you consider it like this, it is going to be like a triangle, and this is 6A by 16 and this is 6A by 16. Now if I want this side, I will be having 6A by 16, which is X center of mass square plus Y center of mass square. Before going to that, they gave you the diagonal is equal to 80. That one we have to use. Diagonal they gave it as 80 centimeters. 80 centimeters. Now when they say that diagonal is equal to 80 centimeters, from there I will take this triangle which is of the sides of a square, one is A, another one is also A, then this side it is going to be A square plus A square, and it is going to be 2A square. So root 2A is going to be your diagonal over here. So from the question they gave you, root 2A is going to be equal to 80 centimeters. Now if you try to find A from there, A is equals to 80 by root 2. So I got the value of A also, I will write it over here. A is equals to 80 by root 2. A value I found it, and I am writing A value over here, which is 80 by root 2. Now let us try to use all these values and find out the diagonal over there. Now let us see, they ask you from A the center of masses, from A the center of masses. Now when I take that triangle and try to find out, then I will be getting root over X center of mass square plus Y center of mass square. Now X center of mass is 6A by 16 whole square plus Y center of mass is 6A by 16 whole square. This is root over. Now when you consider that, you can write it like root over 2 into 6A by 16 whole square. Now you can write that like this. Root 2 into, you can write it as 6A by 16 into root 2. Okay, 6A by 16 into root 2. Now we know the value of A. Let us try to substitute that value of A. If we try to substitute the value of A, I will write it like 6 by 16 into root 2 into A, which I will write that value of A as 80 by root 2. 80 by root 2. Okay, A value I just substituted. Now what happens? root 2 gets cancelled. And what else will be left over here? 80 into 6 by 16. I'll write it over here. Finally, you have been left over with 80 into 6 by 16. Now when you solve this, you will get 480. 6 is 48. So 480 by 16. 480 by 16, how much you will be getting? You will be getting around somewhat 30 centimeters. Right? So, right. You will be getting 30 centimeters, which is option 2. Hope this is helpful for you. Let us meet in the next assignment. Until then,